Hello everyone, welcome back to the channel. Today we are going to discuss topic 9 in data structures and algorithms, which is the Chinese Postman algorithm. Now before you panic, because the name sounds scary, let me tell you one thing. This is actually a very logical and real-world problem, not some abstract theory. The Chinese Postman algorithm is used to find the shortest possible route that covers every edge of a graph at least once. And yes, this topic is closely connected with graphs, degrees of vertices, and Eulerian paths. So if you understand those basics, this algorithm becomes much easier. In this video, I'm going to explain everything from scratch, why this problem exists, what it means, how Eulerian concepts are involved, and finally how the algorithm works step by step using a simple example. I'll explain this in an undergraduate-friendly way, using simple language, not heavy mathematics. So let's start with the motivation behind this problem. To understand why the Chinese Postman algorithm exists, let's think about a real-life situation. Imagine a postman who has to deliver letters in a neighborhood. He must walk through every road at least once, because every road has houses that need delivery. Now, the postman has two goals. First goal, cover every road. Second goal, walk the minimum total distance. He doesn't want to waste time walking extra roads unless absolutely necessary. If we convert this situation into a graph, road junctions become vertices, roads become edges, distance becomes edge weight, so the problem becomes a graph problem. What is the shortest path that visits every edge at least once? This exact problem is called the Chinese Postman problem. The name comes from the fact that it was first studied by a Chinese mathematician, and it became popular using the postman example. But this algorithm is not limited to postmen. It is also used in garbage collection, street sweeping, cable inspection, and even network maintenance. Now let's formally define the Chinese Postman algorithm. The Chinese Postman algorithm is used to find the shortest closed walk in a graph that covers every edge at least once. The keywords here are shortest, closed walk, and every edge. Closed walk means the path usually starts and ends at the same vertex. Unlike some other graph problems, this algorithm focuses on edges, not vertices. That's an important distinction. In many graph algorithms, we care about visiting all vertices. But in the Chinese Postman problem, the main goal is to cover all edges, even if we visit some vertices multiple times. To solve this problem efficiently, we rely heavily on Eulerian graph concepts, which brings us to the next section. Before we can understand how the Chinese Postman algorithm works, we must clearly understand Eulerian paths and Eulerian circuits. Let's start with the basic idea. An Eulerian path is a path that visits every edge exactly once. An Eulerian circuit is a special type of Eulerian path where the path starts and ends at the same vertex. Now here's the most important rule you need to remember. A graph has an Eulerian circuit if and only if all vertices have even degree. A graph has an Eulerian path if and only if exactly two vertices have odd degree. And if a graph has more than two odd degree vertices, then it has neither an Eulerian path nor an Eulerian circuit. Why is this important? Because if a graph already has an Eulerian circuit, then the Chinese Postman problem is already solved. We can simply follow that Eulerian circuit and we will cover every edge exactly once with minimum distance. The real challenge arises when the graph is not Eulerian, which is the case in most real-world networks. Now let's talk about the core idea behind the Chinese Postman algorithm. Suppose our graph is not Eulerian. That means it has odd degree vertices. The algorithm does not try to avoid those vertices. Instead, it asks a very practical question. How can we modify the graph so that it becomes Eulerian, but with the least possible extra cost? The modification is done by adding edges to the graph. But again, these are not real edges being built. They represent retracing existing paths. The postman might need to walk along some roads more than once, and that's okay, as long as the total extra distance is minimum. The algorithm identifies all the odd degree vertices, then finds the shortest paths between every pair of odd vertices. After that, it pairs those odd vertices in such a way that the sum of the added path lengths is minimized. Once these paths are added, all vertices become even degree, and the graph becomes Eulerian. Finally, we simply find an Eulerian circuit, and that circuit represents the optimal route for the postman. Now let's go through the step-by-step process of the Chinese Postman algorithm. Step 1. Check whether the graph is Eulerian. If all vertices have even degree, stop. The Eulerian circuit is the answer. Step 2. If the graph is not Eulerian, list all the odd degree vertices. Step 3. Find the shortest path between every pair of odd degree vertices. Step 4. Choose the pairing of odd vertices that results in the minimum total distance. Step 5. Add those paths to the graph, making all vertex degrees even. Step 6. Find an Eulerian circuit in the modified graph. That Eulerian circuit is the solution to the Chinese Postman problem. Let's understand this with a small example. Consider a graph with 4 vertices. Suppose 2 of these vertices have odd degree. Since there are exactly 2 odd vertices, the graph has an Eulerian path, but not an Eulerian circuit. To solve the Chinese Postman problem, we duplicate the shortest path between those 2 odd vertices. After duplication, both vertices now have even degree. The graph becomes Eulerian, and we can find an Eulerian circuit that covers every edge with minimum total cost. This example shows how the algorithm converts a non-Eulerian graph into an Eulerian one in a systematic way. Before we finish the video, let's talk about the advantages and limitations of the Chinese Postman algorithm, because this is something that is commonly asked in exams and also helps us understand where this algorithm is actually useful. Let's start with the advantages. One major advantage of the Chinese Postman algorithm is that it guarantees the minimum total traversal cost. This means the algorithm does not just find any path that covers all edges. It finds the most efficient possible path, even when the graph is not Eulerian. This is extremely important in real-world applications. For example, in garbage collection or street cleaning, covering all roads is mandatory, but minimizing fuel cost and time is equally important. Another advantage is that the algorithm is systematic and reliable. It does not rely on guessing or random traversal. Instead, it follows a clear mathematical logic based on vertex degrees and shortest paths, which ensures that the solution is optimal. The Chinese Postman algorithm is also very flexible. It can be applied to weighted graphs, which makes it practical for real-life networks where different roads have different distances or costs. Now let's talk about the limitations. One major limitation is computational complexity. When the graph becomes very large, the algorithm becomes expensive because it requires computing shortest paths between multiple pairs of odd degree vertices. As the number of odd degree vertices increases, the number of possible pairings also increases rapidly, which makes the problem more complex. Another limitation is that the algorithm assumes the graph is connected. If the graph is disconnected, meaning some edges cannot be reached from others, then the Chinese Postman algorithm cannot be directly applied without modifying the graph first. Additionally, the algorithm focuses only on edge coverage, not vertex coverage. So if a problem requires visiting each vertex exactly once, this algorithm is not suitable. Finally, in very large real-time systems, using this algorithm may not be practical due to memory and processing constraints, and approximate solutions may be preferred instead. So overall, while the Chinese Postman algorithm is powerful and optimal, it is best suited for medium-sized, connected graphs where exact optimization is required. So to conclude, the Chinese Postman algorithm is used to find the shortest route that covers every edge of a graph at least once. It works by identifying odd degree vertices, adding minimum cost paths to make the graph Eulerian, and then finding an Eulerian circuit. This algorithm has many real-world applications and is an important topic in graph theory and data structures. Thank you guys for watching.